Hi, do you ever get that feeling when you're at the store and all of the bananas are green to the point where they probably taste more like a raw potato rather than a banana? Well, me too. So today, I decided to use a little bit of chemistry to solve this problem. But first, we have to talk about how fruits and vegetables ripen. When a fruit or vegetable reaches its final size, it begins to undergo various biochemical reactions, including the production of ethylene, which triggers the synthesis of pigments, sugars, and other compounds that contribute to ripening. And so today, I want to make some of this unique but yet easy to make gas and see if I can make my green bananas turn sweet and yellow in the least amount of time possible. To do that, I'll need two main ingredients: absolute ethanol and concentrated sulfuric acid, which in my case is in the form of drain cleaner. First, into a test tube, I add 20 milliliters of ethanol, on top of which I then add 10 milliliters of sulfuric acid. And by the way, don't worry about the red color, it's just the dye that serves as a safety indicator to distinguish the acid from other clear liquids and won't affect the desired reaction. I also ensure to add the acid dropwise and slowly, since if done otherwise, it can cause the alcohol to start boiling. Once ready, I set up the following gas collection system and begin to heat the mixture up to 190 degrees C. Now, unfortunately my heating mantle decided to randomly break, and so I had to spend the next half hour replacing the power switch. Once back and running, I decided that for a higher yield of ethylene instead of diethyl ether, it wouldn't hurt to get the temperature up to 200 C. And while my mixture is reacting, fun fact, apples that are usually sold at any standard grocery store are on average 3 to 12 months old. To keep them from rotting this whole time, they're covered with a wax coating and kept under an inert atmosphere in a large refrigerator. Then, a few days before being sold, the apples are put into an ethylene-rich environment to enhance their taste and color. And now here is where I hit my first challenge. What I didn't think about is that the alcohol would start to boil much earlier before any sufficient amount of ethylene was made. So the next day, I set everything up once again, but this time with a stirring bar to prevent flash boiling and the condenser to only let the gas escape. There also seemed to be a leak in my gas adapter which caused the balloon to shrink. Despite it, I still had plenty of gas for experiments, and first I wanted to know that this was indeed ethylene, and to do so I just made some soapy bubbles. Now it is time for bananas. For the best view of my next experiment, I decided to use 2-liter jars with a single banana in each one, as well as two different control groups, one where the banana was completely exposed to the air and the other one with the banana closed in a jar containing no ethylene. As for the rest of them, I would have an increasing concentration of ethylene going from 1 to 5 to 10 and finally 15 milliliters of ethylene. After the preparation, I now had to simply add the needed amount of gas using a syringe into each jar. I then quickly set up the spot where I was going to film the time lapse in order to have a closer look at the ripening of each banana side by side. Important to note here that I chose the greenest bananas possible, so this did take 5 days instead of usual 2 days when it's done industrially on just slightly unripe bananas, despite the fact the difference between the far left control group and the far right is quite obvious. It was now finally the time to take a closer look at the results. First, we see that the two control groups don't really differ that much in color, and the reason why I wanted to do two different controls was because I wanted to see if the ethylene produced by the banana itself would be sufficient enough to create a visible difference, which, well, didn't turn out to be the case. I then wanted to lay the bananas out side by side to see how much color change was from left to right. As a side note, when I opened the jars, the smell inside was indeed quite pleasant and very sweet. As you can see, the color pattern isn't super clear, but it's definitely there, and after adjusting the saturation of the video, I got even a better view of the smooth color change. Remember, these bananas were harvested at roughly the same time, and if not for the ethylene, they would all still be green. Next up, I wanted to do a quick texture and taste test. The very first banana that was simply exposed to the air was very firm and the peel didn't really want to separate from the flesh. The second one wasn't much different and still very hard. Now, onto the third one, which is where things get interesting, with just 1 milliliter of ethylene making the banana much softer. The fourth, the fifth, and the sixth bananas were also very soft, but didn't differ too much from each other. This is mainly because for the volume of air I had in my jars, the amount of gas needed to visibly speed up the ripening would only need to be as low as 2 microliters, or 1/1000th of a milliliter, which means that all of my jars with gas had a way over the needed amount. And finally, the taste test, where I give each banana a rating from 1 to 10 based on whether I taste more starch or sugar. Number 1 and number 2 were almost the same, with number 2 being slightly sweeter. Number 3, however, tasted like a good and perfectly balanced by taste banana. Same could be said about the rest of the test subjects, but with a lot more juiciness to the texture. Now, as for the rest of the ethylene, I added some air to it just to show you how energetic it can be when in the presence of an oxidizer. Anyways, I hope you enjoyed and see you next time.